Hello everyone, and in this episode I'm going to talk about complex numbers, factoring, and rational expressions. So let's get started. So complex numbers, what are they? So complex numbers is given as the expression a plus ib, where I is the imaginary unit. Imaginary unit. Okay, I has a value of -1. Let's say if we have a square root of 4. What's the solution of a square root of 4? It must be 2, right? Or -2. What if we have square root of -4? Then what's the solution? Is it 2? No, because 2 times 2 is positive 4. Is it -2? No, again, because -2 times -2 is positive 4. So, so there's no solution for square root of a negative number. This is where I comes to play. So remember that square root of a times b is the same thing as square root of a times square root of b. So we can write this expression as square root of -1 times 4, right? Hence, we can make it as square root of -1 times square root of 4. So square root of -1 is I, right? So I times square root of 4, which left us with 2 times I. So the solution for square root of -4 must be 2i. It works for everything. So square root of -16 is equal to 4i. Square root of -25 is equal to 5i. And we can prove this also, that if we have a times I times a times I, okay, it will be a squared, right, times I squared. What's I squared? So if we squared I, this thing will be squared also, which will be -1. Well, I haven't go through this yet in the series. So if we have an expression square root of a equals to b, then if you want to find a in terms of a equals, then we must take the square of both sides. A equals to b squared, because this both cancels. Why? Because remember, the square root is the same thing as a half. So a to the power of half to the power of 2. Again, remember the power, if there's multiplication, that means this can cancel. They can multiply together. Then a to the power of 1. So a equals to b squared. So I squared must be -1. So we have negative a squared, which is inside the radical. Now, if we have a plus ib, then 2 plus ib. I'm not gonna explain this much deeper, because this is gonna be part of maybe in the later episodes, where I'm gonna talk about complex numbers in deeper. Also, there is um, subject or course called complex analysis, where we talk about complex numbers much more deeper. So 2 plus, let's say, a plus ib. If we had a equals to 2 and b equals to 1, this would be 2 plus b, 2 plus I. If we had, if you guys remember, the Pythagorean theorem states that a squared plus b squared equals to c squared for a right triangle A, B, C. Well, if we take the absolute value, remember absolute value. So absolute value of A is the same thing, A square root of A squared, right? The modulus of 2 plus I, let's call a complex number as Z. So Z equals to A plus IB. Okay, Z equals to A plus IB. This is just to replace this term because this is quite long. So I'm going to make it into a Z. So Z is a complex number, right? So if we take the modulo of Z, it's basically the same thing as the square root of A squared plus B squared. Okay? So that's just our, if we look at it, that's just our C. There's a lot of application for this. And again, there's something called the conjugate. The conjugate Z conjugate is the same thing as A minus IB. So you just make the positive sign into a negative sign. Likewise, if you have Z to conjugate to the power of a conjugate again, it will take back to the original Z, which is A plus IB. Okay, that's it for complex number for now. So in the later episodes, maybe I would dive in deeper, but I'm not sure because in the journey map, on in the journey, there's no, I believe there's no complex numbers in the later episodes. But let's see if I'll add it in, so, and then I'll explain more, a little more deeper about complex numbers. I'll talk about the argument and also Euler's formula and how to graph a complex number in something called Argand plane or Argand graph. Okay, that's for the complex numbers. I hope it's quite clear. Next, we're going to talk about factorizing. Factorize x plus, if we have two variables x plus y times x plus y. What does this equals to? So here we use the FOIL method. U times x and y times y, x times y and y times x and y times y. What we get is x squared, right? X times x, the same um, base within the same power. It's in power of 1 if there's no number. X squared plus xy, x times y, plus y squared, plus y times x plus y squared. And remember that xy equals to yx. So this is called commutativity, but um, we can ignore the name for now. So xy equals to yx. So we have x squared plus xy plus yx plus y squared. since these both are the same, 2 of xy plus y squared. Okay, x squared plus 2xy plus y squared. This is the same thing. And if you can see that this is the same thing as x plus y squared. Okay, how about we times this as a negative x minus y times x minus y. Um, so y x times x times negative y, and then y times. So x times x must be x squared. X times negative y is negative xy. Remember that the operation follows negative y times x, negative yx, negative y times negative y will be positive y squared. What we have here, x squared minus 2xy, they're both the same, plus y squared. And you notice that this is the same thing as x minus y squared. How about we have the difference, x minus y and times x plus y. What will we have? So x times x will be x squared, x times plus positive y, xy, negative y times positive x, so negative yx, negative y times positive y, negative y squared. What we have here is x squared. This is gone because they're the same and they minus, so xy minus yx will be 0, and then minus y squared. So this is the same thing as x minus y times x plus y. Okay, well, we can actually use a plus b do this. So instead of using the FOIL, we can do this x times a plus b plus by add by y times a plus b, and you distribute them. This works for every, so x minus y, and you follow the negative sign. So wait, no, because in the first one there's no negative, so y plus y times x minus y. What if it's a negative? So x minus y times x minus y. Again, it's x times x minus y. Since y is now negative, negative y times x minus y. Um, Remember, we can, if this was a minus b, right? We can actually switch them, so it will become a minus b times x minus y. It's the same thing. So this will be a times x minus y, and minus b times x minus y. Okay? How about three factors? X plus y times x plus y times x plus y. What is this equals to? Well, we know that um, x plus y times x plus y is x plus y squared, yeah? X plus y squared, and then there's x plus y. We know this is actually what? X squared plus 2xy plus y squared. So x squared plus 2xy plus y squared. And we times it by x plus x plus y. Then when we distribute this, again, this is so x times x squared, x times 2xy, and then add by y times x squared, we have x cubed plus 2x squared y plus xy squared plus yx squared plus add by 2xy squared and add by y cubed. Well, we can group things. X cubed, so x cubed add by y cubed is add by 2x squared y, and is there a same one? So yeah, y x squared. We have 2, so it will be 3, yeah, 3x squared y plus by xy squared. So there's 2xy squared, so 3xy squared. Yeah, that's it. So we have x cubed plus y cubed, and then 3x squared plus y, and then plus 3 times xy squared. So this is our formula for x plus y cubed. There's another formula, which is the perfect cube. If you have a cube, the difference of cube, I mean, minus b cube, it's the same thing as a minus b times a squared minus plus 2a only plus ab and plus b squared. The addition will be a minus b, a plus b, and times a squared minus ab plus b squared. Okay, that's for the formulas. So you can substitute an x and y, so xy. Also this one. So that's how you distribute things, and then do the FOIL method. This is the FOIL method, and this is if you distribute it this way. And what if we're trying to factor out factor out um, say if it was a polynomial, well, we already know that this will be x plus y squared, right? If we have x squared plus 5x plus 6, how do you factor this? How do you factor this quadratic? Now, to factor out a quadratic, we must know the form first. So ax squared plus bx plus c is a quadratic. Okay. Also, I forgot to tell that a polynomial p is said to be ax an x to the n, and then add by an minus 1 x to the n minus 1 plus add until a to the 1 and x plus and add by a naught. This is the general form of a polynomial. general form of a polynomial degree n. To factor out quadratic, we have some sort of number. Let's remove the a first. So the coefficient of 1x squared will be 1. So we must to know a number that if we add, let's say, p plus q must be b, but we times it, p times q, it must be c. So example is x squared plus 5x plus 6. When we add the two numbers, it must add to 5, but if we times them, it must go to 6. So 6 has 1 times 6, right? And also it has 2 times 3, negative 2 times 3, and then negative 1 times negative 6. This is all the possible multiplications of 6 in the integers. So we need to find which one adds to 5, positive 5. So 1 plus 6, 7, 2 plus 3 is 5. Oh, so this is correct. If we negative 2 plus negative 3 is negative 5, which is not. Negative 1 minus 6 is negative 7. So the solution, the final solution must be like x plus p times x plus q. So the factorial form must be x minus 1 and oh sorry x plus 2 and then times x plus 3. That's the form, the final form. Well, we can check this by distributing them. I'm going to use this method, which will get x squared plus 3x plus 2x plus 9, 6, sorry. So we have x squared plus 5x plus by 6. Okay. So it's true. What if it has the coefficient? So the highest degree has a coefficient. So let's say it has 2x squared plus 5x plus 3, let's say. X squared plus 5x plus 3. To solve this, we must multiply 2 by 3. So x squared, there's multiple way to solve it, but this is the fastest way in my opinion. So 2 times 3, 6, and then we need to factor this out. The factorized form must be what we already know, which is x plus 2 x plus 3. And since the original we have 2, we must divide both sides by 2. And if it becomes a fraction, we move the 2 inside or as a coefficient of the x. Okay, let me show you. So if we divide the constant by 2, the a coefficient, what do we have? X plus 1 and then x plus 3 by 2. Since this becomes a decimal, we move 2 beside x. So 2x plus 3, x plus 1. So this is the factor form of 2x squared plus 5x plus 3. Let us prove it. So if we times x by 2x plus 3, we have 2x squared plus 3x plus 2x plus 3. And oh, it's the same. 2x squared plus 5x plus what, 3. So it's the same. Let's do another example. Let's say if it's a negative 2x. Now let's do x squared minus 7x, okay, plus 10. So we need to find a number p and q which adds to negative 7, but it multiplies to 10. Well, we need to have find the all possible multiplication of 10, which is, let's start from 1. 1 times 10, negative 1 times negative 10, and 2 times 5, and then negative 2 times negative 5. Let us check. So if we add them, it's not equals to negative 7. At this, not equals to negative 7. At this, not equals to negative 7. That means this must be the solution. So negative 2 and negative 5, because they add to negative 7. So the solution must be x minus 2 and then x minus 5, because they add to negative 7 and they multiply to 10. When we prove it, it's the same thing. So x squared minus 5x minus 2x and minus plus 10, well, it's the same thing as our above here. How about we have trinomial at degree 3. If we have x cubed plus x plus 1, well, we can't really um, factorize it because we don't have the formula for it. There is an actual formula, but I'll teach it that later. Well, instead, we can either, if the expression this form, the perfect cube and a cube plus, well, we can factorize it into this. But in the case of, we can't factorize it. We cannot. So, I mean, we can factorize x squared times x cubed plus x plus 1 plus 1. Well, this is the factorized form, which are plus 1. If we had like x cubed plus xy, say x cubed plus, say 8y cubed, then we can factorize this, or even just 8, because this is a perfect cube. So this will become x plus 8 times x minus xy, which is x squared minus 8x plus 64. That's the factorized form of the perfect cube. We just use the formula. Another example is if we have x cubed plus a b plus y cubed. Well, since a squared b can be factorized, we can factorize x cubed plus y cubed with the before formula, and then we'll just factorize this. You factorize this, and then you add by a squared b. uh, if we have x cubed plus 7x squared plus 7, no, plus plus nothing, well, we can factorize this. We just need to find the greatest common factor. 7x squared, 49x, which is 7x plus 1. Well, this is the factorized form. Another example would be, say we have x y cubed plus a cubed y cubed. I mean, this would become y cubed times 1 plus a cubed, right? The greatest common factor is y cubed. And we can use the formula, which is this formula. Sorry, this formula to find the factor form of 1 plus a cubed. Or we just directly use this. So this becomes a y cubed plus a plus times y, a times y cubed. So that's for factorization. How about rational expressions, and how do we factorize rational expressions? So if we have 2x plus 1 over x plus 1, this is a rational expression. Well, we can split them. Add by 1 plus x plus 1. The property of rational expression is that if we have polynomials or linear, if we have an expression p and q, or even p plus q, p plus minus q over any expression t, that means p over t plus or minus q over t. If we have p over t again times q over t, this is the same thing as pq over t squared, or this is m, and then that will be t to the power of m plus n. Well, rational expression will be the same as every other rules that I've teach. So let's say if we want to simplify this. So when we want to simplify this, or put them together, we cross multiply, which would become 3 times x plus 3, and then add by 2x times x plus 1 over x plus 1 times x plus 3. This looks familiar, right? So if we have a fraction 2 over 3 plus 4 over 7, then we will use the same technique. So we find the lowest common multiple, and then we times the other numerator by the lowest common multiple divided by the denominator of the expression, the other expression. The same technique, 7 times 2, add by 3 times 4 over what? 21. So it would be 14 plus 12 over 21. This would be 26 over 21. So what will we get is 3 times x plus 3 plus, let's just distribute it, 3x plus 9 plus 2x squared plus 2x then x plus 1 times x plus 3. Is this, can we simplify this? I don't believe so. So uh, I, can we cancel the numerator and denominator? So 2x would be 5x plus 2x squared plus 9 over the expression t. Well, I'm not gonna write it again. So we have 2x squared plus 5x plus 9x plus 1 x plus 3. So since we can't really simplify this, so we leave it as this. Another example would be, say if you have a quadratic at the top, if we were to factorize this, as we know, over look at this, are the coefficients or and the constant is a multiple of 3, we can take them out actually. So 5x plus 6, well this is the same as the numerator. This cancels out, 1 over 3. And another example would be if we had like x squared plus x over x plus 1. How do we simplify this? Again, find the greatest common uh, lowest common multiple, no, the greatest common factor of the numerator. Since they're both the same variable, we can separate x. Oh look, they're the same. We can cancel these. This will become x. So that's the simplified version. So more questions and practice will be on the final unit, on the final um, episode of this unit. And for this video, I think it's done. Yeah, factorization and rational expression. For the next video, I'm going to review a review on factorization, because um, yeah, just to review factorization and then move on to the material that I'm going to share with you guys. So this is it for today's video. I hope you guys understand, and see you on the next episode.